So today we're going to take a look at solving word problems with inequality. So if you think about the words in the word problem that indicate the symbol is going to be less than, greater than, less than or equal to, or greater than or equal to, what are some of those words? Okay, so at least, at most, is a minimum. You have no more than, you have no less than. These are all words that indicate you're going to have an inequality symbol. It's nice when they tell you to write an inequality so you know for sure, and then it's nice when they tell you to write the equation. So at the top, the first star just says recall. Okay, to be a solution to a system of inequalities, your answer must fit all constraints. Okay, so it must be in that solution set. And sometimes word problems lead to inequalities, and we can solve them graphically or algebraically. So on the front page, we're going to do graphically. On the back, we're going to do algebraically. So go ahead and read number 1, underlining your key statements. If you look at the actual grid, it tells you what your variable for x is and your variable for y is. On the grid, down below, it says our x-axis is number of bags of soil. So x is the number of bags of soil, where y is the number of plants. Title of the graph is plants and soil that Marcia can buy. So Marcia's buying plants and soil for her garden. The soil is going to cost $4 per bag, and the plants are $10 each. She wants to buy at least 5 plants and can spend no more than $100. So we're going to write a system that tells us of linear inequalities. So I'm going to write down the variables. I want you to focus on writing the 2 inequalities. Our first inequality comes from the statement she wants to buy at least 5 plants. The plants is the y. So according to 5, the y has to be at least. So that means the y can be equal to 5 or greater than. The other statement, she can spend no more than $100. Well, the spending comes from here. $4 per bag, and the plants are $10 each. So $4 per bag of soil, which is x, and then $10 per plant, which is y. How does that compare to 100? She wants to spend no more. So this over here is the amount that she's spending. Sarah? Less than? Okay, so she doesn't want to spend any more than 100. Can she spend exactly 100? Yeah. So less than or equal to. So both of those lines, they're going to be solid dotted, one solid, one dotted? Solid. They're both going to be solid because of the equal to. Okay, so now we're going to graph. To graph, they both need to be in the form y is, or solve for y, and the first one is. So we graph it as if it was y equals 5. So here's an intercept of 5. Bless you. We said it's a solid line, and is a y equals line horizontal or vertical? Horizontal. So we graph it as if it was y equals. Okay. And then we're going to graph all the values greater than 5. There's the equal to, the solid line, and then greater, would that be above or below? Above. So I'm going to label this as y greater than or equal to 5 before I shade. The other inequality is not in terms of y is or y equals. So we have to isolate y for the next one. So to isolate y, the first thing we want to do is subtract 4x. we'll have 10y is less than or equal to negative 4x plus 100. Divide by 10, 10's cancel, and we have y is less than or equal to. Because we can't divide 4 by 10, we leave it. Negative 4 tenths x plus, and then 100 divided by 10 is 10. 4 tenths can be reduced. In simplest form, that would be what? 2/5. So y is less than or equal to negative 2/5 x plus 10. So to graph this, our y-intercept is where we begin, which is at 10 on the y-axis. And then the m, the slope, how we move. So our y-intercept 10, and our slope negative 2/5. So we're going to go down 2 over 1, 2, 3, 4, 5, down 2 over 1, 2, 3, 4, 5. And you guys have your straight edge, so you can line up your ruler and draw a solid line or a dotted line. Solid. So down 2 over 1, 2, 3, 4, 5. That's going to hit where on the axes? Can I graph? What did we say it was? 25. So that won't have an arrow. We're going to shade above or below? Below. So I'm going to label it first. Our label would be 4x, the original, plus 10y is less than or equal to 100. So I'm going to shade, so it's a little bit different. I'm going to go this way. My solution set is going to be right here. Okay, everything's labeled now. Use the graph to determine if Marcia will be able to buy 10 plants and 8 bags of soil. Well, plants was the y, 8 bags of soil was x. So is 8, 10 in our solution set? No is correct. So if you go to 8 and then go up to 10, that's right here. 8, 10 is not in that solution set. So the answer is no. Next one. How many bags of soil could Marcia buy if she wants to buy 8 plants? So if she wants to buy 8 plants, I'm going to highlight that in pink. 8 plants is here, and this is what's in the solution set. This does to state all possible solutions. So which, okay, I should have actually drawn a solid line. So for 8 plants, that could be an option. There's how many bags of soil? For this point right here, though? 0, right? And you said 5 was an option, right? Yeah. So for 5 bags, that's an option. So 5's an option, 0 is an option. Any others?
Everything in between.
Everything in between. Okay, for whole bags of soil, that would be 1, and then 2, 3, and 4. And then last, if Marcia knows that she needs to buy 4 bags of soil, what is the maximum number of plants she can buy and still stay within her budget? So in green, 4 bags of soil, what's the maximum? So that's going up. The maximum number would be, Elijah? 8. So 8 bags. I'm sorry, 8 plants rather. Maximum number of plants. So in number 2, D has at most $150 to spend on restocking dolls and trains at her toy store. Dolls cost $7.50 and trains cost $5. D needs to fill her shelves, but has room for no more than 30 toys. Write a system of inequalities to solve this problem. So I'm going to use D for the number of dolls and T for the number of trains. So based on the fact that she has at most 150 to spend, and dolls cost $7.50 and trains cost $5, that inequality would be 7.50D plus 5.00T is at most means less than or equal to 150. And then what's the other? So the other comes from she has room for no more than 30 toys. So the number of dolls plus the number of trains is no more than 30, so it can be 30 or less. Part B says D knows that there are only 7 dolls available to order. So she knows that D is equal to 7. Is it possible to buy the rest of the toys as trains to stay within her budget? Okay, so her budget, she has at most 150 to spend. So is 7.50D plus, for D I'm actually going to plug in the 7. We know we have 7 dolls, plus 5.00T less than or equal to 150. So $7.50 times 7 is $52.50. I need to subtract that from 150 and then divide by 5. Subtract, we get 97.50. Divide by 5. And T is less than or equal to 1950. Well, T represents the number of trains, so it's really 19 and a half. Can you buy 19 and a half? No, so the greatest value less than 19.5 would be, okay, so if T was 19, okay, the other inequality was that D plus T is less than or equal to 30. So if I plug in the 7 dolls she knew and had the 19 trains, what's that a total of for toys? 26. Okay, that is less than or equal to 30. So to answer the question, okay, the first part said, is it possible to buy the rest of toys as trains and stay within our budget? Is that the yes or no? Yes. Second part, let's move that up. So yes, she'll stay within her budget. And still fill the shelves. Will she fill the shelves? No. Full would be how many? 30. So did she fill it? No. Yes, she'll stay within her budget. However, she will not fill the shelves. All right, number 3. Brittany wants to bake at most 15 loaves of bread for a bake sale. She wants to make banana bread that sells for $1.25 each and apple bread that sells for $1.50 each. She wants to make at least $24 in sales. So I'm going to let A equal the number of apple loaves and B the number of banana. The first inequality is that she wants to bake a total of apple and banana of at most 15 loaves. So the number of apple and the number of banana, it can be 15, but at most would be less than, yes. The other inequality comes from the statement that she wants to make at least $24 in sales. Well, she's going to get $1.25 per loaf of apple, and then $1.50. Nope, I had that backwards. Banana, apple is $1.50. $1.50 apple, $1.25 banana. So at least $24 means she can make $24 or no? Greater than. Part B, Brittany knows that she has enough ingredients to make 6 loaves of apple bread. Okay? So we know that A equals 6. So with the A plus B, that goes with how many she wants to bake. If we know she's going to make 6, that means she's going to bake how many banana?
11.
Nope.
9.
9. It can be equal to 9, right? So we're good. It didn't come out to be a decimal. So if B is 9, and A equals 6, the question says, is it possible for her to make the rest of the loaves as banana bread and still make enough money in sales? So let's plug in $1.50 times 6 plus $1.25 times 9. 150 times 6? Yep, because $1.50 is 3. And then 125 times 9? 1125 for a total of how much money? Is that greater than or equal to 24? No. So it said, is it enough? So all you need to say, or is it possible for her to make? The answer is no, and we just justified mathematically. So we just need to say no.